We're finishing 1.1 with additional homework.
Hey, what class are we in?
A geometry.
Hey, it's geometry, and today we're going to finish up 1.1, as Andrew just said, and we're going to do a few examples. So, lots of time today in class to work on stuff. I'm talking really loud because as I was looking at the videos, when I walk away, that doesn't pick it up as well. I'm going to try to get me a wireless lapel mic. Or not, I don't know, I haven't decided.
The streamer mics?
Yeah. Oh, welcome back, chat. Cool, let's get into it. So, here's the deal. I like to do examples, like your book has examples, a ton of examples. Here's what I try really hard and very intentionally to do. I don't necessarily love the way that your book, if you were doing this independent study, I don't love this book for independent study. I just don't think it's good, it has really great stuff in it, but the organization that would benefit you guys just isn't quite there. So, here's what you'll see. They do, in this textbook, they show some examples of stuff here. Okay, so we don't have to look that closely at this. Here's an example where it looks like they're going to use the segment addition postulate. Okay, your book has this example. We're going to do an example like this. I'm not going to do this example though. It'll be very similar because I want you to have the example that we do together and the example that the book has, so you have multiple if you need to use your book. Here's the issue though. When I make up an example, do I always take the time to ensure that that example is going to have a really nice, clean answer?
Yeah.
No, never. Like, unless I prep it way in advance, which I don't, is it like no reason that our examples would have nice answers other than in like textbooks they usually do? Is an answer of 1.4392 okay?
Yes.
Yeah, it's just as good as an answer of 4. Like, they're equally likely. In fact, I would argue there are way more ugly numbers out there than there are nice numbers. So it'd be weird if we only ever got nice ones. So here's our quick start today. In our example, right off the bat, we are going to use these postulates immediately. So using some of these postulates. Now, I'm going to leave it up to you guys to help me decide if we're going to use the segment addition or angle addition postulate. But here we go. On example A, let's say we get segment, we'll go J, K, L. So J and L at the ends, and then somewhere between them, I would try to not make it look like the exact middle. We're going to put point K. All right. Now on top of this, I'm going to say that from J to K, above it, I will write 3N. Now, just a convention here. What do you think has a length of 3N?
K and L.
JK.
Oh.
So we wouldn't say J and K. You have to give me a segment if you're giving me a length. It could be JK, it could be KL, or it could be JL.
KJ.
So JK, right? Okay, how would I write this if I wanted it to be JL? Like the whole thing. If I wanted to say that the whole thing had a measure, where would I write the number for it? Or how would I write that down? So, go on.
You couldn't.
So you couldn't do it nicely, right? Not like this. We're going to do a couple things. When I write, I don't know, 5n minus 1 right here, what do you think I'm saying has a length of 5n minus 1? Vincent. Which segment has a length of 5n minus 1? KL. Do you guys all agree with that? Okay. Now, your book doesn't do this. I've never seen a textbook that does this because, Ray, you're absolutely right. It'd be hard to do the whole thing. If I want to specify it's the whole thing, what I do is I'll add something like this next to the picture or below it, above, whatever the case is. And now when I write something like, I don't know, 29, what do you think 29 represents the length of? The whole entire thing. And or alternatively, and that's a great point, Ray. It depends on the situation, what we're writing. I will do this, or I'll tell you that the length of JL is 29. Both of them are completely valid. When you're labeling pictures and stuff, if you want to be able to put 29 on it, this is how I'd recommend writing it. Okay, your book will always present it like this, just like you suggested, Ray. So, what do you think we're going to find? So let's find n, let's find the length of segment JK, and let's find the length of segment KL. Okay. We are going to write this out more detailed than I probably would, or maybe you would. First thing I want us to do is I want us to make sure that every single one of us really and truly agrees with this segment addition and how it works. I want you guys to hook it up. If I wanted the length of JL, are there smaller pieces that we could combine to make it according to segment addition? What are they, Andrew? This whole segment, what two smaller segments would we need to put together? So, good. I'll say something plus KL, and I'm like, you could write KL first. I just do it in a particular order. So you've added this part. What's the other part we need to add? JK. No, I'm serious. Everybody on the same page. Like, that seems okay. All right, Raylene, you can sit in front of Ashley if you want. So you can you can slide a desk all the way up if you really want to. I can slide that table over. All right, but once you can see, because I can't either, like I lost my glasses, I don't know where they are. Is there anything that we can plug in for these? Like, do you know what JL is? Hey, well, that was neat. Man, how about JK? 3N. And KL? Love it. Okay. So here's where I have really bad habits. Some of you guys in here can probably do this without writing a single thing down. Not everybody can. I think I can. I'll probably combine steps from time to time. If I do something on the board that you're not sure how it worked, what are you going to do immediately?
Ask a question.
You're going to ask. Now, I won't always do like the T-chart where you show me add one, whatever the case is. But let's see here where you guys are at with this just math from Algebra 1. Ashley, what's the first thing you would do when solving this? Okay, so by combining like terms, what's 3n plus 5n? 8n. And what's still on the right side still? Minus 1. Everybody okay with this? Okay? Carson, what would you do next if we're trying to solve for n?
Draw balance and plus one on both sides.
When you say draw balance, you're doing this thing, right? So I typically don't draw the T-chart. It's literally never do I. If you guys want to, is that cool? For sure. I'll try to remember, you said to add 1 to each side of the equal sign. I normally won't always write this either. If I don't write this and you don't know, let me know immediately. All right, so we do that. What's on the left side then? 30 equals 8n. Now we're trying to solve for n. We'll have only n on one side, but we don't want to solve for 8n. We want to solve for 1n. So right now, n is multiplying by 8. Everybody see that and agree with that? Geez, how do you undo multiply? How do you undo multiply by 8? Divide by 8. So I'll try to, at least as we get started, divide by 8 and divide by 8. What happens when you have 8 divided by 8 on this side? They don't cancel. That sounds like magic. That's fake. What do? Do you remember the words that we used in? So, two ways. Cancel, honestly, you're correct when you say it. I know what you mean. But I think that it does make it seem like maybe you could do it without understanding it. What's 8 divided by 8? They one out is informal language, or they divide out. I like that. I will always call you out for saying cancel, even though I know you're right. Okay, on the right side of this equation, then I have n. Does this simplify? Does anything go into 30 and 8? What goes into both of them? What?
Well, I mean,
4.
if you're just trying
So
to
4 times what? So first, are they both even? So I'm going to simplify this fraction is all I'm going to do. 2 goes into the 30 15 times. 2 goes into 8 how many times? 4. Does this simplify anymore?
Yes.
No, not directly. Now, Harbor, you're absolutely right. If you want to take a calculator or do the mental math, 3.75 is a good answer. Is this also a good answer?
Yes.
Yep, I will take this. We have n. Now, for the next part, maybe it won't be as nice. How many of you would prefer decimals rather than fractions?
Miss Hall, I have one quick, how did you get 29 though? Or did you just make it up?
So it was just here.
Oh.
Yep, we were just told that this was 29. Great question. Okay, I will use approximately, or it's exactly equal to 3.75 because I think it'll be a little bit more natural if we're talking lengths. Okay, are we done?
Yes.
Why not?
We need to solve for JK and KL.
Yeah, we need these two pieces. So check it out. Calculators in here. I have not decided that I'm going to let you guys take any home yet. We will eventually. In fact, probably starting tomorrow, I'll be okay with that. But let's see. There's how many of you guys in here?
6 right now, but 7.
6 right now. Little calculators or big calculators? Why big? Okay, if you will return these at the end of the hour, I don't know why you put 3 on your desk. Please return these at the end of the hour. We'll figure out the checkout situation with them all. I'll have these sitting up at the front class, probably in that folder up there. Okay, these are like the big graphing calculators, your TIE course from last year that you had. These do a few way nicer things than those. So I'm going to show you guys because there's a few things that you don't quite understand. Raylene's mind's already blown for some reason. What? Oh, good. All right, so check this out. There's a few really handy things that here's why I won't check out the calculators for you. If we're looking at this, we had 15/4, right? Okay, or it was actually 30/8. So check out right off the bat. If I do 30/8, if you look on your calculator, there is a specific button that says let's do fractions. So here it is, n over d, numerator over denominator. If I put in 30/8, turns out that your calculator is also annoyed by this. We simplified that to 15/4, right? Check it out. 15/4, right off the bat. Okay, if I want to get a decimal with it because maybe I don't want to use this. If I hit second enter, I can get the same screen, or I can just scroll up and get it. If I add a decimal, it'll know that I want decimals now. So 15.0, or just 15 point over 4, and here's our 3.75.
I didn't realize there's so many ways to get the decimal piece.
There's other modes. I like the pretty print, and we'll see why eventually, because this will save us a ton of time. So now that we have these calculators, how could we find JK? What do you want me to plug in? So JK, we know, is 3 times, what was N? 3.75. And go ahead and ask your calculators, what's the value of JK then? 11.25. Deal. That was a calculator. I'm going to put all my answers together. JK is 11.25. In the past, I've been absolutely crazy about units. Your book is not, so I will not. Okay. Now, if we know that this is 11.25, there's 2 different ways that we can get KL at this point. What's one of them? Yeah. We could take 29 minus this JK, which we just found is 11.25, and we would get KL. You could just straight up subtract it. Or, what's the other alternative?
Plug in for KL.
Yeah, we could plug it into KL and say 5 times 3.75 minus 1. In either situation, I think we're going to get 18.75, right? Minus 1 is 17.75? So here we go. We have an answer for N, we have an answer for JK, and we have an answer for KL. That's going to be ugly. 17.75?
Well,
Did you remember to do your minus 1? And you can always check, right? Like, if this is a quiz, you don't have to wonder, am I right? What do we know that these two had better add up to?
29.
29. You can check to verify that that is indeed the case. Is this a crazy hard problem? Okay. Do we need to do another segment one, or should we switch gears and try to do angle addition? Okay. So this time, I'm going to say, Vince, I'm going to make you move so you can talk with somebody. I don't care where you move when we work this problem, but let's do an angle problem together. So here we go. We're going to draw a kind of ugly picture. Our pictures will not always be to scale. We will try to make them work as best as we can, and let's just see what we're coming up with here. Okay, we're going to be told, we're just going to get a picture right off the bat. Oh, we should get real crazy with this. How crazy should we get?
Super crazy.
So crazy. Okay, deal. Here we go. We're going to draw a picture here. We're going to first draw angle JML, starting at point J up top, J to M to L. Juliet, Mike, and Lima. JML. All right. From JML, I'm going to have a ray shooting out in the middle of this angle that we'll call it MK. Drugs are bad. I don't know if South Park's still popular or not. I don't know. All right. So check this. Your pictures. Did I give you guys straight edges last week? Okay, we're going to try some new straight edges today. I'll pass them out here in just a minute. Here's what we're going to do. Instead of drawing stuff in the picture, I'm going to give you some given information here. Here's what we know about this figure. I'm told that this thing, whatever this says, and I'm going to ask somebody to tell me what this says. Who's comfortable reading the left side of this to me? Okay, hit it, Ray. The measure, or the measurement. The measure of angle JML. If you're going to put a degree symbol, I have to have this. Okay, so we know that that's 80. Furthermore, we are told that the measure of angle Kilo Mike Lima, KML, was equal to 33 degrees. All right, I want you to find for me the measure of angle Juliet Mike Kilo. Find Juliet Mike Kilo. Now, on quizzes, tests, things like that, I will always give you the illustration with stuff. I give you the illustrations so that when you're doing these on your own, you can draw your pictures. Okay. Is there information I can put in here easily? Like, can I label JML? This is going to be a weird one. To label a large angle, just like we did with the segment, I would make sure it's really clear that we're talking about the whole thing. Here is angle J to M to L, and what's its measure? 80 what? Degrees. You should always draw on your picture. If you ever come to me for help and you don't have a picture drawn, I will not help you until you draw the picture to try to make sense of it. Okay, Andrew, where should I put the 33? I have two options. It could be the top or bottom.
Bottom.
Why? You're correct, just so you know. I just want to see if it was a guess or if you had a reason.
Just looks right.
Okay, so you are right. When you see angles, remember the order matters. K to M to L, did it form that bottom angle? Yeah, like I follow the order. So right inside of here, I'm going to put 33 degrees. And I will use a single arc to indicate if it's unclear that that's what I'm talking about. Okay, we'll do one more harder one after this because this is just very intro. Gosh, if I wanted to know the measure of angle JML, according to angle addition, are there two smaller pieces that we could add up to get that bigger angle? What's one of those measures, Carson? Angle?
Angle J and K.
Juliet, Mike, Kilo. And Ashley, what angle would I have to add to that to get the big one?
What?
So if I'm using only angle addition, the big angle, JML, its measure is the sum of JMK, the top one, plus, how would you name the bottom one? Angle. Good. This part, it's probably tedious, and it feels tedious to you, it feels tedious to me, but it's good practice to make sure that we understand this postulate. Is there information we can plug in? Okay, what am I going to plug in for the measure of angle JML, Juliet, Mike, Lima? 80 degrees equals, anybody know JMK? Without giving me just the answer in the end. We don't know it yet, do we? What should we call it? Some unknown. X is reasonable. I will put an X right here so that my picture makes sense. Plus 33 is the last one, right? Can you guys solve for X? What would one subtract from both sides, Vincent, to solve this for x? Boom, I'll subtract 33 from the right side of the equal sign. I will subtract 33 from the left side of the equal sign. And we then conclude that x, or measure of angle JMK, is that what was actually presented? Angle JMK ought to be what angle? 47 degrees. And we're done. The hardest part is being able to set it up. Now, they can get harder. They can get a little bit harder. They don't have to get crazy challenging. Let's get one more, a little bit more complex, and see what we can come up with. So here we go. Last one. I want you guys to work this together. I'm going to pause it. We'll just do a quick check to see if it goes okay. And then if so, you will have a ton of time to work on homework, and we'll probably play with protractors a little bit. So I'm going to have angle XWZ right here. And I'm going to put this little box thing on it. So here's X for X-ray, W for whiskey, and up top is Z for Zulu.
Wait, is that the what's it called? Like Alpha Bravo drum?
Yes, the NATO.
I didn't know
Yep.
W was whiskey.
Yep. Only time I'll let you talk about whiskey is if you're saying double letter W. What does this boxy thing mean?
90-degree angle.
90 degree. Give me another name for a 90 degree angle.
Right angle.
Right angle. If two angles add up to 90, they are complementary. Yep. Cool. All right, so from here, we're also going to introduce Whiskey Yankee, just shooting right out through there somewhere. I don't pay attention to the scale at all. I just know it's in between. All right, this time I will give you guys, instead of writing it out on the side, I will give you the stuff in here. I'm going to make my marker a little bit finer. So let's see, inside of X-ray Whiskey Yankee, we have a lovely angle told to be 5x plus 5 degrees. 5x plus 5 degrees. Inside of my other angle, which it's kind of too small to write, so I'll use a little arrow, we're told that it is 2x plus 8 degrees. I want you guys on this problem, the only actual answer I need is the measure of angle Yankee, Whiskey, Zulu. I'm going to pause it. I would like to hear you guys chatting it out. If you're struggling, and let's say Carson's struggling and Andrew answers a question that Carson has, but it doesn't make sense to Carson, who should Carson ask next? Hook it up. I ain't got nothing to do but help you guys. Like, that's my job. Make me get paid. Make me work for, I don't know. Do the problem. If you're struggling with it, if we were to take, I'm just going to name, we'll use, yeah. If I were to take the measure of XWZ, so that's just this one right here, right? If I were to add that to the measure of YWZ,
Oh wait, I got it wrong.
right here, what should those two add up to?
20.
Why 20?
Because the x isn't really any, it's just the symbol, so it's technically 5 plus 5, and then the same thing with the x next to the 2 is 10, and then.
So I would really caution, don't make assumptions about what X is. We don't know yet. Like, we'll get there. You told me the answer that I was looking for a second ago. What do you know the whole big angle is, according to this mark?
90.
So if you take a small part and the other part, what should they add up to?
90.
Boom.
Oh.
Now we'll kick in. How do we label, or what do we say XWZ was? I have the wrong angle, don't I? Is that what confused you? I think that's what confused you. This should be XWY. That's my bad.
Oh.
Not your bad. I'm sorry. Then, okay, let's put in Y here. What do we say XWY was? On our picture, how do we label it? X to W to Y. What's that angle?
It's in parentheses.
5.
5. Keep going. 5X.
5x plus 5.
Okay, so that's that blue angle, right?
Oh, yeah.
When we add to this the red angle, what do we say that YWZ was?
2x plus 8.
And together, these two add up to what?
20.
Y20.
5 plus 5, and then.
So we can't ignore the X.
Oh, okay.
Like, check it out. All I've done is I've substituted in for the left side. What did the right side say before?
90.
So what should it still be if we haven't changed it?
90.
90. Now we can deal with the x's. Are there like terms that we can combine?
Yes.
What 5x and 2x adds up to
7
7x, and 5 plus 8.
equals 13.
Okay, so we're just cleaning it up. That's equals. Sorry. If I want to solve for x, what's the next thing you would do?
Right.
How do you get this out of this side? What should we subtract?
90.
So you could subtract 90, but what if I just want to make this one disappear?
Oh,
What undoes a plus 13?
minus 13.
Boom. We'll do it to both sides.
Okay.
Okay, 7x equals 77. How do you make 7x change to just 1x? What undoes a multiply by 7?
Subtracting.
So subtraction is the
Divide.
opposite of addition. Yeah, divide. X is equal to 11. Are we done? And did you get x is equal to 11?
I did.
Okay. Why aren't we done?
Because
What are we looking for?
It's a good question. What did I ask you to find?
m degrees y w z.
So we're going to clean that up. I'm going to make you repeat after me. When you see the m here, it's the measure of angle.
Oh, measure.
Right? Measure of angle YWZ. So that was this one here, which is 2x plus 8. We know x at this point. So if we just plug in, we'll write it out. Measure of angle YWZ was equal to 2 times x. What did we just find x was?
11.
Boom. And plus 8 still, because it has the plus 8 on it. What's 2 times 11?
22.
Plus 8?
30.
Check it out. We got 30 degrees for that bad boy. Okay. As we go through, it takes practice. Setting it up, drawing the pictures is going to be a huge part of getting through these, especially if you're struggling. If there's a picture associated and you don't draw it and you come ask for help, what am I going to tell you?
Draw the picture.
Yeah, leave me alone. Go draw the picture. Come back. I want to help, but I want you to try to help as well. So, these ideas feel okay, feel awful. Any questions from anybody here? All right.
Are you going to turn that one off?
I will. We're about to start homework stuff. Yep. All right. So, you guys want a really, really long homework, right? Bless you. All right. You're welcome. So here we go. Homework. We get 23 minutes in class today. I will just put it on Google Classroom right away so we can see what it is. We're third hour right now? Cool.
I have to do it.
All right. Today is the 25th. Finish lesson 1.1. Homework. I'll do it in bold. Homework 1.1 you will find starting on page 11. I might be off a page or two when I'm doing this from time to time. Where in your book would you find homework 1.1 assignment?
I just don't need space.
What if I didn't tell you page 11? How would you find it?
1.1.
Yeah, go to section 1.1 and then just go to the end. Like it's in your text. Okay, did I give you guys textbooks?
Yes.
That's a fisheries book, just so you know, Harbor. Okay, I want you guys to do problems 9, 12, and 15 through 41 odd.
Page 11.
Starting on page 11. Yep. And then you guys, I'm going to ask that you'll help me remember this. But what I'll try to do after every homework assignment is I'll show the book so that if you wanted to watch it, like just see the homework problems at home, you could. Here's the weirdest thing about this textbook. There are no answers in the back. There are no answers in the back of your textbook. Okay, I don't think I agree with that. So what I will do is figure out how to get you like a PDF of the odd answers. Andrew?
Is it 9 through 12 odd? And-
Nope, only the 15 through 41 is the odd part.
Oh, that's all.
How much is that? Questions?
Yeah, but you get 20 minutes right now. So,
Well,
yeah, it looks like a lot. Yo. Yes, that's fine. The other thing, if you've ever been a crier with math homework, we're going to set a hard limit, 40 minutes outside of class. If you go home and you're working on homework for 40 minutes and you get like a third of the way done, stop right there. If any of the assignments that I give you can't finish in that amount of time, it says, hey, we should probably address something else. and I will help you to make sure that you can, in the future, do it in that amount of time. All right, you're good, Ashley. Don't even need to sign out.
I got it.
Yeah. You should try to bring your books to every class.
I know, I just forgot
Yep,
about
you're
it.
good. Cool. All right.
Would,
Go ahead.
would like, I don't want to say the answer. I don't know if I'm reading number 9 now. Is it just, well, can I say what I think it is?
Yeah, sure.
Is it just like 1?
It wouldn't be 1, because then mn would only have a length of 1. Or if n was equal to 1, then mn would have a length of 11.
Oh, so
Like-
n would be 12-ish? I don't,
I would sketch it first.
I don't understand.
So, like, on a number line, m starts at 11, right?
Yeah.
And the distance between m and n is 12. There's 2 possibilities for where n might live. Miss Janae, what can I do for you?